Let us now see some examples of inverse functions. Consider this function f from integers to integers defined as f of x is equal to 3x plus 2. Now, f of x, I'll take it to be an element in the codomain, rather the range. I'll write it as y. So, y is what? It is equal to 3x plus 2. Let me compute x from this equation. Y minus 2 is equal to 3x and hence x is y minus 2 by 3. So, what is x? X is the inverse of y. Rather, x was mapped to y and hence f inverse y happens to be y minus 2 by 3. Pause and think how the steps have proceeded and you'll be able to understand it better. So the inverse of every element y belonging to the range of this codomain is y minus 2 by 3. Consider this function f from the set of all real numbers to integers defined as f of x is equal to greatest integer function, that is the square bracket of x. We see that f of 0.32 is 0, f of 0.45 is 0, f of 1.798 is 1, f of 1.45 is 1, f of 1.32 is 1, and so on. So do you see that several elements will be mapped to 1? Now, how do we find the inverse of 1? Let me tell you, the inverse will be unique. One element cannot be having 2 or 3 inverses, right? You must know that by now, by the definition of function. So will it be possible for us to find an inverse here? Definitely not. But let us reason this out. If f is from R to Z, f inverse will be from Z to R. What is f inverse of 1? It will be associated to several numbers in the real line. And hence, it will not be a function, and therefore, we cannot find the inverse of this function. It is not invertible. The last question, if f is a function from R to R defined as f of x is equal to x by 2, so I'm taking the half of that element each time. What is the inverse here? F of x is y, so what is y equal to? X by 2, and therefore what is x? Very simple, it is 2y, right? So f inverse y happens to be 2y.